Okay, so what we're doing today, we're going to fill in on the paper that I just gave you a bunch of answers to these formulas. Tomorrow we'll take a quiz that's just like this answer key that you're about to create. So I'm going to start off with the circles because that's the freshest one in our mind that we just did that yesterday. So on Friday, I gave you a formula for area of a circle. Can anybody remember what that looked like when we did on Friday, the area for a circle formula? I'll tell you, it started with an A. For what obvious reason did we start with an A?
Because that means area.
A for area. How did we do the areas Friday? Pi was in there, so that's the pi symbol. So we're filling in the bottom right corner now. It's like number 10. And then with an R with a little 2. We're going to do pi times the radius squared. We're using these letters to represent words, to represent ideas, and write this in a shorter way. Because if you use words and wrote the sentence, to find the area of a circle, you multiply pi times the radius times itself. That's a fairly long sentence. This is a much shorter way to write that. Take the radius times itself times 3.14, that gets you the area. That's a formula for circles. I'm going to ask you to memorize that and try to do that tomorrow. Circles don't have a perimeter. This whole column was titled perimeter, but circle, it's not called perimeter. What's it called? Circumference. So what am I going to put for that variable?
Circumference.
C. So C equals, how did we do the circumferences when we just got done doing set U?
Diameter.
Times.
Pi.
Times pi. So we're going to go pi times the diameter. What do you think I'm going to put because of the diameter?
D.
A D. So there's a formula for circumference of a circle. We're going to take the diameter times 3.14. That gets us the circumference. That's a formula for that. What do you think all the area formulas are going to start with?
A.
A. So the whole way down this right edge for all of these area formulas, just put A equals A equals A equals A equals all the way down. What do you think we're going to put down the whole perimeter row?
P.
P equals. So P equals P equals P equals P equals right down the perimeter row. Does anybody remember what was special about triangles? There was something about triangles that we only did for triangles, only for the one answer. Does anybody remember what we did special when we did triangle work with shapes before? It had to do with the area. Areas of triangles, we did something we didn't do for anybody else. Then we cut them in half. So the area for formula for triangles, we're going to need to get a half in there. That's the only one that's going to use a half. But the area, we're going to throw a half in there for the area of a triangle. No other fractions are going to be on this thing. Let's do rectangles first. Okay, so you don't have to draw this. I'm just going to draw this to help us think it out. For rectangles, rectangles have two sides. One is usually called the width. One is usually called the length. It doesn't really matter which one you call what, because if I have a rectangle and you think that this is the width, and you won't give me credit that this could be called the width, because you insist the width could go this way, how could I kind of make you look bad? And show you the width can go this way if I feel like it. Just turn the paper. It doesn't matter what you call what, because like, whoop, both, who cares? Okay. But for rectangles, one of these would be called the width, one of those would be called the length. Can anybody describe just with words, how do you find the areas of rectangles? If you know the length and the width, how can you find the area of a rectangle? What do you do with math? You just take the length times the width. You just multiply the numbers. So we know from life that we could write a sentence that says to find the area of a rectangle, you multiply the length and the width. If I want to instead do that as a formula using some variables, you just write
W times L.
W times L. I'm going to write L times W because for some reason math people tend to go in alphabetical order with their letters more often. Would it be wrong to put W times L? No.
No.
It's just as you see it in books and things, it's usually the letters go more alphabetically. I don't know why, they just do, it's just a thing. But if you write the letters backward, there's no harm. So this, if you wrote D pi, that's fine. However, on this one, if you wrote R pi squared, why would R pi squared be wrong?
Because you would square the radius.
The square has to be with the radius. So you could write R squared then pi, but you can't switch where the power is going. It's got to stick with R. How about perimeter? If we wanted to do the perimeter on this rectangle, what would you do?
Add
You'd add. Who would you add?
L and W.
You'd add the length and the width, but then you'd have one more thing to do after you added the length and the width. Perimeter adds up everything, and some of these don't have labels on them. So after you added these, what would you have to do to take into account that there were more stuff?
Find like the missing.
We could, but we know what those are, so we could do a little bit of a shortcut. If we just added up the two that we knew, how can we shortcut our way to the total? What's going to be true about those compared to these?
Or does it just add up the total and the sum
Yeah,
of the two?
yeah. And since these are the same as those, once we add up the couple that we know, what would be the quickest way to get the total? Just multiply by 2. Okay. If I want to show in math symbols that I'm going to do this first, how do I show what I'm doing first? Parentheses. So I'll go parentheses for that to do that first, and then I can multiply by 2. So this is using math symbols to do a replacement for the sentence. Add up the length and width first, and once you're done, multiply by 2. That gets you the perimeter. I could write that in a paragraph if I wanted to, but this formula is a quicker way to do that. So now, whether you want to memorize these straight out, or whether you want to think them through the way we're kind of thinking them through now, is up to you. It doesn't really matter to me. But we just need to get a finished product on this when we start taking these as quizzes. Parallelograms. Parallelogram, I could draw you that. Let me call this B, because it's called the base. Let me call that S, because it's the side. If I want to do the perimeter, how would I use the base and the side to come up with a perimeter kind of a thing, the way we just did the perimeter for a rectangle a second ago? How would you get the perimeter if we knew these?
Add them.
Add who?
B and S.
We'd add the base and the side, yeah.
And then you separate, like do the parentheses.
We'll do the parentheses because we'd add them first, agreed.
I don't know the rest.
Okay, then we'd have one more little thing to do. We're close. Anybody a thought how we'd get the whole perimeter after we added these that we know? How would we get a grand total to include the other ones?
Add
Yeah, we'd want to go ahead and multiply by 2. So these look almost the same. They're almost the same strategy of add up the two that you know, and once you did that first with the parentheses, multiply by 2. It's just different letters, because rectangles are called lengths and widths for some reason, and parallelograms, they usually call them bases and sides. If I want to do the area, I'd have to improve my drawing. Memory of how I'd have to improve my drawing for a parallelogram?
Make a line straight up.
Yeah, I'd go like, what kind of line did I usually draw? Yeah, straight up and down, but a certain kind of line, a dotted line. So if I draw a dotted line in to measure straight up and down, that's usually called its, what word do you think would measure something that goes this way?
Width.
Height. That's usually called a height. You know, if we measure my height, you know, we're measuring me this way. So if I'm trying to measure a shape this way, that's often called its height. So if I want to do the area, which of the letters matter? Base, side, height, which two?
Whichever line makes a right angle.
Yeah, the right angle, which is gonna be the,
The base,
and
height.
the height. So this is gonna be a base times a height, that's true. Question about that? Let me do a triangle. So triangles also have a base. For triangles, do I also draw in a height? Did we do that for triangles when we were doing areas? Yes, we did. Triangles had a base. Triangles had a height. The only difference about triangles was the half we already discussed. It's going to be basically the same formula as parallelograms. We take the base times the height, and then we need just half of that. Question about triangle area, almost the same as parallelogram area, it just involved having it. Let's go squares. For squares, Crash, how many numbers did I always label you on a square? Why one? How can I get away with only one?
Because all the sides are the same.
They're all the same. So I could just call that S, because it's one of the sides. So S for side, that's all we need is one label, one letter. How would you do the perimeter? How would you figure out around the square how far it is?
This number times 4.
We would take that number times 4. Just take 4 times the number that we've got. How would you do the area for a square? It's kind of like this. This we took length times width. That got us the area. This we did the base times the height. That got us the area. Areas, we always multiply 2 things. This was base times height, got us the area. We just had a little weird because it was halved. Square, who times who?
S times S?
We could go S times S. I would not mark wrong S times S, but I would prefer to write that a little different way, although S times S would be correct.
That was S times S times S.
No, that got us colder. What would be a better, quicker way to write S times S?
S with a 4?
No. S times S.
S squared.
S squared. Just put S with a little 2 instead of S times S. What you don't want to do on any of these is use this for your multiply symbol. Why do we not want to use this for our multiply symbol ever
Because
on
you'll think
this?
it's a letter.
Because we might think that's another letter. So you can just write the letters next to each other is simplest. If you wanted to show multiplication another way, what way could we do that would be fair? A dot. We could do the dot. We could also do the parentheses to multiply, which we did show on a couple of them. I skipped this one, saved this one for last because it's a little different. I'm going to have to draw myself another picture of another triangle with some new labels and teach you a thing I think you've never heard of until I do it in 30 seconds. For a triangle, how would we do the perimeter? How do you do perimeters for a triangle?
Just like since
Just without worried about the formula yet, not worried about the symbols yet, just with words, how do we do perimeters of triangles?
You multiply the sides.
No multiplies. Areas, we always multiplied a couple numbers.
Right.
Perimeters never really involve multiply, unless it was a shortcut. So like here to add everything, we took a shortcut and multiplied by 2.
Does it add the sides?
We add all the sides. So I cannot say S plus S plus S. That would give a false impression. If I called these all S's, why does that give you a little bit of a false impression about triangles?
because the sides are not the same.
The sides aren't all the same. So if I said S plus S plus S, it makes it seem like maybe the sides are all the same because they all have different names. So here's a thing that happens in math, borrowed from the English language. There's a thing called subscripts. Subscripts are little numbers that go like down in the ground. I don't know how sciencey you've ever gotten, but you might have heard of water being H2O. Okay. That little 2 is written as a subscript. It's like down sort of into the ground. Subscripts are low numbers. These exponents can be called superscripts. A superscript means it's a number or a little thing that's up. Subscript is down. So when you have different things that are similar, their subscripts are used. This is side number 1, this is side number 2, this is side number 3. They're all still having the S because they're all sides, but the subscripts just go to show you they're different. It's side 1 plus side 2 plus side 3. So one thing you want to try to just get straight and ready in your mind as you practice this, the perimeter triangle goes subscripts. Superscripts on the 2 exponents. The square has an exponent, the circle has an exponent. Everything else is just all like at the same level. But another place you'll see subscripts one day. Here's a physics formula. It's a thing called the combined gas law that someday maybe you have with me. Gases have a thing called pressures. Gases have volumes, they take up space. Gases have temperatures. This is just telling you both of these numbers represent pressures, but they're different. Both of these numbers represent some kind of volumes, but they're different. Both of these represent temperatures, but they're different. If the temperature or pressure of a gas changes, it can change other things about it. But that's a formula using subscripts to just kind of illustrate the point of this. Sometimes you have 2 of this like similar kinds of things, but you just use subscripts to say they're different. If you're talking sports, this team won games and that team lost games. You could call them W's and L's. But if you're talking about another team that wins and loses games, this might be wins number 1s and loses number 1s. That's win number 2, loses number 2. The subscripts are just a way to show these are 2 different teams we're talking about, and they both have wins and losses. Question about what that all means? Okay, if you want practice papers of that, I'll give them, but not right now because I'll just stick here while we're recording and do that. But I have some spare practice papers just like the ones I gave you. If you want an empty one to take with you, we could go with it. But question about those? Either today or tomorrow when we have time, I'm going to do a math of one of each shape to do that, but I don't know if we're going to have time today before the bell rings, so I'm going to put that on hold. What I am going to do today is do a little bit of math with you for a thing called surface area. Am I still on screen if I go this far to write the words surface area?
No.
A little bit of a turn needed maybe? Good enough for that zone?
Yes.
Okay. So surface area is for 3D shapes. I'm not going to grab the blocks and bring the shapes back down here. I will stroll over here though and grab my tissue blocks. We can look at that one. What was the name of this shape? A box like this? That is a rectangular prism. So the idea of surface area is a little different than volume. We've done volume before. Volume's the space inside the box. Like if I wanted to take blocks and fill this box up with blocks, I'm talking about volume. What I'm talking about today is surface area. Like if I wanted to put stickers on here and figure out how many stickers it would take to cover all the different zones on this box. What was each zone called? This flat part of it's called face. This line doesn't matter to us today, but we'll drop in some old words. The lines were called E-word. Edges. The corners
Vertex.
was a vertex. A bunch of them could be vertexes or vertices. Okay, but what we're trying to do today is figure out surface areas. We want to do the total of all the areas of all the faces. How many faces do we have? 6. There's a front and a back, the left and a right, there's a top and a bottom. There's 6 faces on this shape. What is each face going to be? Each face is a what? What shape is that facing you? It's a rectangle. So what we're going to need to do is a bunch of areas for a bunch of rectangles. To do areas of rectangles, we need to multiply 2 numbers at a time. But if we multiply 2 numbers, we'd have this one. If we multiply a different 2 numbers, we'd have this one. If we multiply a different 2 numbers, we'd have this one. And then we'd be most of the way done. If we just get 3 of the faces figured out, how are we almost done?
Because they're mostly the same
The rest are the same. So if we can get a couple of them figured out, we're just gonna have to then, at the end, multiply by 2. So here's what we're doing. If you want a crazy formula for surface area, we'd want to take a length times a width. We'd want to take a length times a height. We'd want to take a width times a height, because there's different combos that we could figure out. Length, height, width, height. Add them up. Do that first, and then we just said to multiply by 2. If that formula helps you, great. If that formula confuses you, don't look at it. We'll just look at the shape. So if I go to look at this shape, what would be the area of one of the rectangles if we multiply a pair of numbers?
For one with the whole would be 32.
There would be a 32. Somewhere in this shape, we could do 8 times 4. 8 times 4 would give you a 32. That would be on the right side, that would be on the left side. There'd be a couple of 32s, because 8 times 4 would get you a couple 32s. What's another pairing we could do other than 8, 4? We could get a 40. There's 8 5s. 8 times 5 is 40. That would be the front, so therefore it's also the back. But 8 times 5, there's a couple 40s there. What's your other pair?
20.
There's a 20 pair. The bottom would be 4 times 5 is 20. The top would be that same 4 times 5 is 20. But what you want to do is all the pairs you could do, add them up. What'll this add up to?
92.
It would be a 92. And then we're going to go times 2, because we only figured out 3 of the faces. There's another 3 faces hiding out there somewhere. Grand total, 92 times 2?
184.
184. That's surface area. Question about that?
So you can do that multiplying with every problem?
Any order, yeah. And so if somebody did 5 times 4 first, it doesn't matter. These can be stacked in any order of a stack. Just get 3 of them, add up your stack, and then times 2. So here's one, it's 2, 3, 10. Let's build our stack. What's one number for the stack?
30.
There's a 30. Doesn't matter if you put that first, middle, or last, but 3 times 10, there's got to be a 30.
6.
There's a 6. I'm going to put that on the bottom because it's going to be the littlest one, but you can put it anywhere in the stack, doesn't matter.
And then 20.
20 is in the stack. Doesn't matter what order you stack them in. I'm guessing when people add, you like the little number at the bottom?
Yeah.
Probably it just looks right, sort of. But how you do this, how you build the stack in order, it doesn't matter. But there's 3 numbers here. There's a 30, there's a 20, there's a 6. Add that up.
56.
56. Then
Multiply by 2.
multiply by 2.
112.
112. Question about that one. Let me change the box a little bit. This makes it probably easier, but maybe it freaks people out the first time you see it. Let me change that 2 to a 3. So is there still a 30? Yes. Is there still a 20? No. What is there instead of a 20?
30.
There's another 30. What's there instead of a 6? A 9. Add that up. 69 times 2 makes 138. If 2 of the numbers in the picture are the same, 2 numbers in the stack will be the same. That's okay. So 10 times the 1 3, 10 times the other 3. Just make sure you get every pair out there. Question about that? What's this shape called? This would no longer be a rectangle. Well, it's still a rectangular prism, but it also has a better, more descriptive name. What shape is this that I drew, if I could draw?
Cube.
It's a cube. What's the deal about a cube? All the sides are the same. So we actually aren't dealing with rectangles now. We're dealing more with...
Cubes.
Great thought, wrong word maybe. They wouldn't be rectangles, they'd be, each face would be a square. We're dealing with squares. So here's a square formula. For squares, we're doing side squared, which means to take the number times
2.
When the side gets squared, we do the number times itself. So if I want the area of one of these faces, we would take 5 times 5 makes
25.
25. Then we're almost home already. How many faces are there every time there's a box?
3, 6.
6.
Oh my god.
And for a cube, all 6 of those are the
Same.
same. So if there's 6 25s that are all the same, our quickest math is to right now take 25
Times 3.
times
3.
6 this time. 25 by 6? 150. For cubes, we would want to do the side times itself times 6. That would be like a shorter formula if you like me using these formulas. If the formulas confuse you, don't worry about it. This, I guess I should have done surface area equals. But we'll do the side times itself and then times 6. We're running close to the bell, so I'm not going to do the math the whole way. But if I change that 5 to a 4, you would go 4 times 4 makes 16, and then 16
Times 6.
times 6. If I made that a 7, you would take
7 times 7.
times 7, get an answer,
49.
49
Times 6.
times 6. It would be weird if it were a 6, because you'd go 6 times 6, and then again, times a 6. There's always at the end, there's a 6. Where we are for homework, there's going to be a little bit of 311, a little bit of 342, mainly a worksheet. So I'm going to hand the worksheet, don't leave without your worksheet. But the top of the worksheet will say what to do on 331, the top will say what to do on 342. So worksheet, parts of some pages, the worksheet has the list. We will take this quiz, let's do this for tomorrow. Only this quiz, guaranteed. We're not going to do the positive negatives, we're not going to do the divisible bys. Only study this one for tomorrow, and I have spare papers if you want them. So let's cut that recorder.
150, baby.